turn the key, a little starter motor drops in, starts the engine off. So we have a little starter motor. It does have a Bendix drive, but I hold it manually. That goes on there, starts the rotor. It first of all tests that we've got actually free rotation, and we can see a free rotation there. That will then tell the computer it's operational. So it then opens this valve here, takes the gas in. There's a normal glow plug here, which is enough to fire the gas. So you'll hear a pop as the gas fires up. What will then happen is the thermocouple at the back will detect that temperature rise. The computer say, okay, the gas is lit, I can now start the fuel pump. So it'll very slowly start pumping fuel in, a tiny bit at a time, and you'll hear the energy pick up as this fuel goes in. As the temperature rises, the gas is switched off, running fully on the kerosene. And so this motor will continue to accelerate. And this one is self-sustaining at about 24,000 RPM. The starter motor will take it up to 28,000 RPM, at which point that'll disengage, I'll just move it off. And then the turbine is giving enough power to drive the compressor there on upwards. And it'll run it up to about 40, then drop back to a steady idle of 36,000 RPM. So at that point, I'm then given control of the throttle. Up to that point, I can do what I like with it, it won't do it. So then I'm given the throttle, and this engine actually is really quite modest. It only does 120,000 RPM. The one in the helicopter there and one of the ones over there, those ones are 160,000 RPM, which is slightly more exciting. At which point this is producing about 14 pounds of thrust. But what I tend to do is take it up to about 100,000 RPM, because you've got the good idea by that point, yeah? So on here, on the computer, we have an RPM sensor which sort of tells us what the RPM is doing. We've got the exhaust gas temperature, which is this thermocouple at the back end, so the temperature of the air coming out of the turbine. We've got these two load cells, so it actually gives us how much thrust there is, but it also shows if there's any offset of thrust. Then we've got the fuel and lubricant lines. So on this side there's two flow sensors. Fuel comes into the first one, but then immediately after it we tee off the lubricant, and then it goes through the second one, which is only the fuel. So one's showing purely the fuel flow, the other one's showing the combined fuel and lubricant flow. Because the amount of lubricant is so small you can't actually measure it. You actually go for the difference. Then we've got the fuel. So you'll see that number go down. That's oh,
I see.
Yeah, the amount of fuel. That's the pressure inside the combustion chamber. So as it's running, you'll see that increasing in pressure. That's the ambient temperature. So that should always remain the same, but it's logging the information. In fact, it's just got colder. And that's the ambient air pressure. So I mean, for any jet engine, the ambient conditions are very important. Because the way a jet engine works, I mean, one of the most difficult answers to give is, what is thrust? Everyone imagines that it's the turbine blowing out the back end. All the turbine is actually doing is taking energy from that flow of air in order to drive the compressor. It's actually getting in the way and actually sort of stopping much of that flow of free air coming out the back end. And in an engine like this, despite its modest size, at full throttle, that turbine is having to give over 20 brake horsepower in order to drive that compressor. It doesn't, I mean, it's about 25 brake horsepower. The remaining energy is where we get our thrust. But the very, very basic, shall we say, the basic mathematics is the difference in speed at which the air goes in, which in this particular case is nil, because it's ambient air, and the speed at which it comes out, and how much there physically is. So air has weight, so the thrust is actually taking that air and accelerating it and throwing it away. So it's like you standing on a trolley with a brick. and throwing it out the back, and that gives you thrust to move forward. What we're doing with the jet engine is the same with air. We're just taking huge amounts of air and throwing it out, accelerating it, and the mass of that is our thrust. And an engine like this at full throttle, we are sucking in about 5 cubic feet of air per second. So there's a lot of air. There's 0.5 kilograms of air per second going through here. So it's quite a lot. So I'll try not to demonstrate what I did earlier, which is because we're not clamped down, I went to full throttle and it started to try and fly. So we'll sort of try to keep control of it this time. Now can I actually ask everyone to come around the front of the engine on the basis this is the dangerous end?